Hello and welcome to another video of me learning C#. This video we're going to put everything we've learned into one movable Starship using the Kenny Sprite Starship. Again, I didn't make any of these sprites. They were all come from Kenny Sprites. But we're going to do quite a complex movement for our Starship. So to go over the beginning of the code, have to explain pretty much everything that's happening right now. So I'm using a pawn Starship. So this is what's going to be receiving my inputs from my controller. The basis is that the player controller, so anybody who has like an Xbox controller or the keyboard, is pushing any of these buttons. These buttons relate to what's happening in the actual pawn, so what it's going to do once it receives those commands. And we can see how everything kind of still works right now. So I'll show you this. So T key still teleports the spaceship randomly. We can use these min and max variables to change the distance on that. But now we have a move speed, which with my arrow keys can move up, left, right, or down using this move speed as a multiplier. When I use my WASD keys, I can still move around, hit the arrow keys to teleport it, and then now we have a shift, which runs off this turbo multiplier. So my move speed's 5, my turbo multiplier is 2, so I'm moving at 2 times the speed. So if I use my WASD keys, and now I hold shift, it moves the spaceship even faster. To see what's happening under the hood, the code, we have this public float turbo multiplier 2F. This is giving us our turbo speed right here. When we come down and to see what's actually getting happening, this, if input key down key code left shift turbo button, it does this speed, which is created from right here, float speed equals speed, sets the variable to speed. This sets the speed times speed equals turbo multiplier. So that's what this little star asterisk and the equal sign. It's speed times speed, or speed times speed equals the turbo multiplier. So this is what it's multiplying under this turbo multiplier to get this function. And that's what's moving the spaceship even faster. We're still using time delta time, so this is going to be independent of frame rate. This is going to go off seconds of in between the frames. So if you have a slower computer, it's still going to run just as fast as if you had a faster computer. And so when it's teleporting around, see how we can see how key code up arrow? So this is when the key code is getting pushed. But we can see how this get key can be like held down. When we say get key down on this, like these lines, it's showing that it has to be, it doesn't matter how long I hold it, it's only going to do it once the key comes down. So it can't be like spammed and keep teleporting off into random directions. It's just the first initial time when I push the key down. And everything's going to be a public variable, so it's able to be edited here in the inspector. We have the move speed, which is the normal speed of the aircraft, rotation speed, a turbo multiplier by how fast it's moving once you press the shift, and our minimum and X values for our randomizer for when we press the T key now. And again, Pawn Starship is the actual ship and how it relates. So if you think of like how anytime you drive a car or play as Mario, this is going to be a pawn. The controller is actual controls that we're inputting into that for it to reference. So anytime we push the rotate, see how it references the pawn here. That's where we're coming into and actually messing with the pawn. And again, anytime we're doing any of this time delta time is how we're actually getting our positions. So it's going to be independent of frame rate that's happening on the computer. It's going to go more off seconds, what it's based off of. So this is any time that it tries to have a slower computer, it's still not going to be moving slow. It's still going to go off the seconds. So we don't have any slower speeds on slower computers or faster speeds on faster computers. And you can see here how we've been using vector 3. So when it's talking about vector 3s, like this one's a great example. It's going to give you a random x, random y, and a z. So this vector 3 is the actual transform component that we can see here. These are what's going to be able to do x, y, and z on our actual parameters here. So this would be anytime we're using a vector, that's what we're calling for, is those specific requirements in the transform. So we have named our transform TF. So when we come up here, this transform is what's actually taking the transform component and named it TF. But we're using the vectors to call out these transform components that are on the inspector window. We can think of these as vectors as like direction of where we're facing and the magnitude of how far we want it to go. So sometimes we'll have like multipliers coming off of the vectors that'll be able to, I guess these float values would give a good example. We can multiply, so think of a distance between this line and this line. If we wanted to multiply it by 2, we'd be making that vector twice as long. So if it took the same amount of time, it would take us longer to reach there. If we wanted to shorten it, we times it by 0.5, which would like cut it in half. And you can see when we're playing our game, we're able to move in local space or world space. So when we're moving in local space, you can think of it as local to the actual sprite that it's moving. It's turning. When I'm using the up, down, left, and right, it's moving in world space. So this is more located to a origin here at the center, or what we can think of it as in a 2D space is it's looking at the screen. It's basing it off of screen movement, so it doesn't actually turn the sprite in any way. This is the difference of local and world space that I'm using. And the reason we use this pawn and controller setup is so we're not trying to write a bunch of lines of code in a pawn or anything like that. So the controller and the pawn, they started it, I guess, in Unreal. It was like a great example how they started implementing this pawn and controller setup. It's a way that we can start controlling individually what's happening on this controller. They're derived from, like here I have a controller class that's the master class of this controller that holds the mono behavior class inside of it. So this is where we can start creating individual classes of like an AI controller or player 2 controller, and all they're doing is referencing the original master class of that we created the controller under that holds the mono behavior script. So everything within the, or not mono behavior script, mono behavior class, anytime that we use this, we're able to like implement pawn starship. So this creates from pawn superclass, which is like the same thing. It holds the mono behavior class. So anytime we wanted to create a similar pawn, maybe it's an enemy spaceship or another spaceship, we can just reference this, and it takes all the parameters from the master class and references it into another pawn so we can use it for other things. This iteration just helps save time. Instead of rewriting code, we can just adjust certain things to match what our other character or other player is doing. And again, all the green writing that we see here is just how I was trying to word everything into like my understanding instead of it being like computer code, because it's going to transport this into ones and zeros. And this is hard enough to try to understand like what's happening here. A public class not giving any feedback to us with a move and a vector 3 in direction. So this is just a way that I can understand what's actually happening from the code that we've learned. And then through all this, we actually have a little playable game to work with. Thank you for your time.